Arithmetic series. An arithmetic series is formed by adding the terms of an arithmetic sequence. So you could think of it as instead as replacing the commas with plus signs. We can find the sum of the terms of an arithmetic series, and we use the notation S sub 1, S sub 2, S sub 3, etc. to denote these sums. So S1 is the sum of one term. S2 is the sum of two terms. S3 is the sum of three terms. And then in general, S sub n will be the sum of n terms, right? From T1 all the way up to Tn. Now, we already have some skills for dealing with arithmetic sequences, right? We know the formula. Bless you. We know that T sub n is T1 plus n minus 1 times d. Okay, and now we have, or we're going to develop a formula for S sub n, the sum of the terms in an arithmetic series. So sometimes I will misuse the words. You can feel free to correct me if you like. So the story goes that, anybody heard of a guy named Gauss?
He's 8 years old.
Yeah, well, we think 7 to 10 years old or whatever, but. So little Carl Friedrich Gauss in school when he's somewhere between 7 to 10 years old, and the teacher, wanting some time, apparently asked the students to sum up the numbers from 1 to 100. 1 plus 2 plus 3 plus 4 and so on. You know, thinking that this will keep them busy for a while, right? But little Carl Friedrich, being a bright little boy, figured out how to do this and came up with the answer very quickly. So the question, well, so how did he do it? So he said, well, here's what I want to do. I want to sum up. I want want 1, whoops. Let's quit that. I want 1 plus 2 plus 3 plus 4. All right, he said, I want to add these up. Then he thought about it, and he says, well, what if I write this same series, but backwards? So if I do that, what's each column of numbers going to add up to? 101. Yes, but he didn't peak with that. He actually went on to do other stuff with his life besides. So how many 101s do we have? We have 100 of them, right? Now it's fairly easy to multiply 101, not to write it, but to multiply. It's fairly easy to multiply 101 by 100. Okay. But if I do that, what's the problem? It's not the answer. What is it? It's double the answer, right? So what do I have to do? Got to divide by 2. So that'll be 10100 divided by 2, which is 5050. So little CFG adds this up, comes up with the answer, 5050. We don't know if the teacher had the answer or not, right? But you know.
She's probably just like, yeah, let's answer.
She wouldn't have been a she. So, sorry, not back when Gauss was. That would not have happened. I don't believe.
I like it.
So you know, you're a little more you're a product of your generation and all of that. So anyway, so that's how Gauss. So let's do this a little more generally, shall we? Because we need a formula. We don't need a trick. We need a formula. Now you also notice one thing here, notation-wise, my t's are curled at the bottom so that they don't get mistaken with plus signs, right? Because it's too easy. So just make sure that I can tell your t's from your pluses, and vice versa. Okay, now what else did he do then? Well, then he said, okay, so S sub n is equal to, and let's start this up the other way. And so how's it all going to end up down on this end? If I write it backwards, T2, and then T1. So, what do each of these things? So now what we're going to do is we're just going to sum this up vertically, right? You know, top, bottom. So what's S sub n plus S sub n? 2 S sub n's. What's T1 plus Tn? That's T1 plus Tn. What's T2 plus Tn minus 1? Well, let's go down to this end here. This is T1 plus Tn. So what do you think each of those add up to? T1 plus Tn, right, basically. And how many of them are there? So how many of these guys are there? Well, the world we were adding up 1 to 100, but how many terms do we have? Sorry? N. We have n terms. So how many of these are there? There are n of them, right? So what's S sub n? So the formula for S sub n is n over 2 times T1 plus Tn. Okay, questions? You don't have to derive it, you just have to be able to use it. Now, there's also an alternate form that we can go with, because we know what's T sub n equal to. I don't know, it goes back to like Thursday, right? It's been so long. What's T sub n equal to? T1 plus n minus 1 times d. So what can we do then, right? We could say, well, S sub n is n over 2, T1 plus, now what am I going to write?
N minus 1 plus d.
What are you saying what he said, which was wrong, and not what I wrote, which is right?
Possibly.
Yeah. Well, don't.
Congratulations.
You left off the T1. You left off the T1 when you said what it was. You said it was n minus 1 times d, and then you repeated it. Okay, sorry then, I didn't hear you. So this will be 2 T1s. Okay, so this gives us 2 possible formulas, yes?
How did you find Tn again?
Thursday. Thursday.
What's it?
Go back in time to Thursday. Yeah.
More horrible at remembering.
Yeah. What's that? That's like totally new stuff, man. We never saw that before in our lives. All right, so for the arithmetic series, 1 plus 3 plus 5 plus 7 plus 9. S1, the sum of one term, is just equal to T1, or 1. S2 is 1 plus 3, which is 4. S3 is 1 plus 3 plus 5, which is 9. What's S4? 16. 16. What is S5? 25. What is S sub n? N squared? Good catch. N squared. It's kind of interesting, eh? When you sum up the odd numbers, that you get the square of the number of numbers what you are subbing up. Summing up. Okay, so 2 formulas for S sub n. You don't have to memorize them. They'll be given to you. And one thing I found out about IBs, they like to give you lots of formulas and that. You get a nice little formula booklet. Yes. So there'll be all kinds of stuff in there, right? Because the emphasis really is not on memorization, right? It's on being able to apply things. Also, you get to do one of your papers without a calculator, so then the emphasis there is on knowledge, not the ability to punch numbers into calculators. So, okay, so here's our two formulas. Now, what do they have in common? What is the same? What do you see in both formulas? You see an n over 2. What else? S sub n. What else? What else do they both have in common? T1. So, the top formula, so you must know or be looking to find one of the four quantities. Each formula has four quantities in it, right? The top formula has S sub n, n, T1, and Tn. How many of those do you need to know? If you know 3, you can solve for the fourth. So you're going to use this formula if you know the number of terms and the first and last term. So you have to know n. You have to know the first and the last term, right? Or you have to know S sub n and the first and the last term, right? Now, if you got 4 quantities, you need to know 3 of them. So in this case, it's first term, last term, number of terms, and sum. This is sum, number of terms, first term, number of terms again, but that's just the same n, right? And common difference. So use this formula if you know the number of terms, first term, and the common difference. Okay, each formula involves 4 quantities. You need to know 3. So you have to ask yourself when you're solving these, what do I know? Okay, and then what am I going to find out? And how am I going to do it? It's the old 4-step problem solving method, right? So let's just do some examples. For the arithmetic series, 6 plus 11 plus 16 plus 21 plus ... Finite or infinite? Infinite, yeah, it's really pronounced infinite, not infinite. Determine the 50th term, which has nothing to do with the sum, right? It's the term, right? Terms are the terms. This is T1, T2, T3, T4. Okay, so what do we know? T1 is
6.
D is
5.
N is 50, and it's T50 that we want to find, right? We want to determine the 50th term. This is Thursday stuff. Has nothing to do with arithmetic series, right? It's just arithmetic sequence stuff. Okay, so that formula also has 4 things in it, right? T sub n, T1, n, and d. You need to know 3 of them. We do. We know the first term, we know the common difference, and we know the number of terms. So the 50th term is the first term plus 50 minus 1 times 5. So that's 6 plus 49 times 5, which is 245 plus 6. 251. Right? Yes? Determine the sum of the first 50 terms. Okay, now that we know the first and the last term, then we can use this formula, right? So we can list what we know. T1 is 6. D is 5. N is 50. T50 is 251, and S50 is what we want to find. We can actually use either formula, right? Because we know everything. The easiest formula to use will be the one, this one. I mean, we can do it both ways, so, you know, let's just start off. So S sub n is n over 2, T1 plus Tn. Okay, that's the easiest formula to use. Okay, involves less. There's more work in the 2t1 plus n minus 1 times d. Right here, what do? Add 2 numbers, then multiply by n over 2. And the other one, you got to multiply by 2, you got to subtract 1, you got to multiply, then you got to add, and then you multiply by n over 2. Right? So using this formula, it's 1 and then multiply by n over 2, and here it's 1, 2, 3, 4 operations, and then multiply by n over 2, right? So you say I could do 1 or 4. I choose to do 1. So S50 is 50 over 2, T1, 6, plus Tn, which is T50, or 251. So it's 50 over 2 times 257. And that works out to how much? 6, 4, 2, 5. Thank you. Questions? Concerns? Seeing none? Let's move on. We'll have lots of chance to use the other formula as well, right? If the first term of an arithmetic series is 12 and the last term is t21 is 172, then determine the sum of the series. Didn't we just do that? Yeah, I think we did, right? Okay, so let's list the information we have. Okay, so there are 5 quantities, right? T1, Tn, n, d, and s sub n. Okay, there are 5 quantities. Each formula uses 4 of those 5 quantities. Okay? So, in this formula, since we don't know d, we are going to choose to use the formula that does not have a d in it, right? Because otherwise we would have 2 unknowns. This and this. Right? We don't know d, we don't know S21. S21 is what we want to find. We're not asked to find d, right? We don't care. What's d? Who cares? Okay, we're asked to find, so let's put the formula down, right? Always write the formula out every time you do any problem, because that way you will write the formula out when it really counts, when you're doing the problem on a quiz, you know, where it counts. And if you get in the habit of not writing the formula out, it's 2 things. One, you won't know the formula as well, okay? And, you know, you won't know the formula as well. You're likely to misuse it. Okay, so you just want to make sure that you write it out every time. Okay, so we are finding S21, which will be 21 over 2, 12 plus 172. Okay, so what does that work out to? 1932? So down in the States, was 1932 an election year?
I don't know. Who cares? It's the States.
How many years ago was 1932?
Long, a lot
Yeah, a lot of years. So many I can't calculate it. How about 80 years ago? If they have elections every 4 years, then was 1932 an election year?
Yes.
Yes, it was.
And that's had like 10 violence.
They still had an election. Determine the sum of the arithmetic series -16, -18, -20, minus ending in -284. Well, there's a problem. What's one of the things we have to know? We have to know t sub 1, which we do. So that's good, right? T sub 1 is -16. What's d? What is it? -2. All right, I heard some 2's, but I think those got changed to -2's, right? What is n? Because we need to know n. What's t sub n? So there's a problem, right? We don't know n, and we have to know n. So how are we going to know n? Thursday. We're going to go back and use the formula, because up there we have sitting the 4 things that are in the formula, right? Because the other thing that's unknown here is S sub n, which is what we really want to find. But in order to do that, we first have to determine n. Right? Got to figure out how many terms there are, because the formula involves using n. Okay, so we go back to Thursday, we say t sub n is t1 plus n minus 1 times d. -284 is -16 plus n minus 1, don't know n, times -2. Okay, first thing I'm going to do is what?
Move 16 to the other side.
Add 16 to both sides, right? So what's negative 284 plus 16?
268.
Negative 268 is, what's the next thing I'm going to do?
Divide both by or multiply.
Okay, so I'm going to divide, right? Because I don't want to expand that all out, right? I mean, I could do that, but that's too much work. You know, like why have negative 2n plus 2, and then instead of the negative 16, have negative 2n plus 14, and then have to subtract 14, and then, you know, divide by 2 or whatever, right? So in solving this, it's easier. Just add the number to both sides, get rid of that negative 16, divide by the negative 2, add 1 to both sides. We got n is 135. Okay, so now I know there's 135 terms. I can work out S sub n. Which formula am I using? Second one, right? Because we don't know d. Sorry, we do know d. So, yeah, we know t sub n. Yeah, it doesn't matter, right? Really. Okay, because now the only thing we don't know is, so the first formula works here, right? N over 2, t1 plus tn. Okay, 135 over 2. And t1 is negative 16 plus negative 284. And what's that work out to? 67 point, no, that's 135 over 2. What's the whole thing work out to?
Minus 24.
Minus 2050? Yes, agreed, not agreed?
Disagree.
20250?
Agree. Oh yeah, sorry.
Minus 20250. Alright, that's not what you said in the first part. Okay, good. Glad we cleared that up. Any questions? Right? Instead of sitting at home with a video, this is your chance to interact. Or you can ask questions. You know, so give me wrong answers. Right? Instead of me sitting at home scrambling for a calculator. Where is the calculator? I gotta work this out. Determine the value of n for an arithmetic series. So this time we have t sub 1, t sub n, and s sub n. So we know the sum of n terms. Okay, we got that. We have to find n, right? N is the unknown. Is there a formula that involves t1, tn, s sub n, and n? Yeah, the first one. Man, are we ever going to get to use the second formula? Soon, I would think, right?
The next one.
Yeah, the next one, because the next one or two.
Example 5. Actually, the next one.
Okay, so write out the formula, right? The first thing you do is you write out the formula. Then you substitute in, so negative 171 is, don't know n, right? So n over 2, t1, 16, plus what? Negative 35. Okay, what's the first thing I'm going to do? What are the first two things I'm going to do in one?
In one step. Add the brackets.
I'm going to multiply both sides by 2.
And add the brackets.
And at the same time, I'm going to add the brackets, right?
Because we're all lazy.
Yeah, so this gives me negative 342 is equal to n times what? Negative 19.
Barely fit in the negative.
Yeah, I know. So what's n equal to? Keeping in mind it must be a natural number, right? 18? So here's, you know, part of the question being a proper question and all that, this has to work out, right? It has to be that n is a natural number. It can't be 0, it can't be negative. N is the number of terms. It can't be 17.2, so if you're starting to get numbers like that, then you've made a mistake, right? So you need to adjust. Okay, any questions? Comments? Concerns? Determine the first term of an arithmetic series if D is 12 and S10 is 360, right? So you got to keep straight. We're not looking for the first term of a sequence. Well, actually, we sort of are. Because the first term of an arithmetic series is the first term of the arithmetic sequence. Okay? So, what are we trying to find when it says determine the first term of the arithmetic series? T1 is what we want to find. Okay? What do we know? What else do we know? Well, we know D is 12. What else do we know? What's N? 10. And S10 is 360. Okay, we do not have T sub N. We do not want to find T sub N, so we will not be using the first formula. We will be using the second formula. So let's write it out. S sub N, N over 2. 2T1 plus N minus 1 times D. Right? And let's fill in. What's the secret to math, right? It's like formula, substitution, answer. We got our formula. Let's sub into the formula. We know that S sub N is 360. We know that N is 10. We know that T1 is T1. We know that N is 10. And we know that D is 12. Okay, so first line is write out the formula. Second line is, okay, and now substitute in. Don't do any calculations yet, just substitute in. Okay, now you can start doing calculations. So 360 equals, since this is even, we can go 5, and we get 2T1 plus 9 times 12. I can divide both sides by 5, right? So 360 divided by 5 is 72. And this will give me 2T1, and 9 times 12 is 108. Okay, so we're kind of doing two things at once, but dividing both sides by 5 and then adding up, or multiplying that number in the brackets there, allowing me to drop that. So 2T1 is equal to negative 36? Yes? No? Maybe? Yes? So what's T1 equal to? Okay, there we go. And we have solved the problem. Saved the world. We have saved the world. I know, usually when they save the world, it's much more dramatic than this, but just for dramatic effect. Example 6. In an arithmetic series, now we get a formula for determining the sum of n terms, right? S sub n is n squared plus 2n. Determine the first 4 terms of the series. Oh, well, that was pretty easy, really, isn't it? So what do we do? S1 is equal to 1 squared plus 2 times 1, which is 3. S2 is equal to plus 2 times 2, which is 8. S3 is equal to, which is S4 is equal to 24. Okay, so the first 4 terms of the series, really it should be the first 4 terms of the sequence, right? This should really be determine the first 4 terms because it's a sequence. So what's T1 equal to? 3. What's T2 equal to?
5.
Yeah, so in other words, what do we add to 3 to get 8? What's T3 equal to? What's T4 equal to? Is 3, 5, 7, 9 an arithmetic sequence? Yeah. T1 is 3, D is 2, right? 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. This actually leads to an interesting result, which they don't really say anything about here, but basically the way you could do this is T sub n, the nth term in the sequence, is S sub n minus S sub n minus 1. Right? So in other words, T4 is S4 minus S3. Right? Because what we're really saying is T4 is the term that you have to add to the sum of 3 terms to get the sum of 4 terms. Okay? So that's kind of an interesting yet unstated result. Right? If I want to find a term, if I take the difference between subsequent sums of series, then I will find the term that you had to add, right? Because to get the next series sum, to get 24 from here, I have to add 9. Well, to get from S3 to S4, I have to add T4, right? This is T1, this is T1 plus T2. This is T1 plus T2 plus T3, and so on. Okay, so I think you're good. You have enough to go on. Lots of questions to do.